All right, let's look at our last example. Okay, here we have the integral of tangent x. If you flip back to your page that has all of your trig identities and all of those integrals, you'll see that we can't integrate. We don't have a straight up formula for memorizing the integral of tangent of x. We have one for cosine, we have one for sine, but we don't have one for just tangent. We have one for tangent squared, but not tangent. So when we are integrating these, the first thing that you need to do is use a trig identity. That's why you had to take pre-calculus before you take calculus, because trig identities, it's a whole unit. So the trig identity that we're going to use, we're going to change tangent into sine and cosine. And the way that we can do that is tangent becomes sine x over cosine x, and then we have dx. Now, at first glance, this may not look like it actually helps us, but it does. So remember, with an ln problem, we're always setting the denominator equal to u if the derivative of the denominator is equal to the top. Well, if we set u equal to the cosine of x, and we took the derivative, so we found du equals the derivative of cosine is negative sine x dx. And on the top we have sine, except for it's just not negative. So all we need to do is put a negative and a negative. Negative on the inside, negative on the outside. So when we integrate this problem, we will have negative integrate negative sine x dx becomes du. Cosine becomes u, and that's on the bottom, so we have 1 over u. So now this is just an ln problem. So we integrate, we have negative ln of the absolute value of u plus c, and we put the x's back in. So our answer is negative ln absolute value cosine of x plus c. Okay, so that's how our trigs would be applied in an ln problem.